Okay, so let's talk a little bit about velocity time graphs. Much like when we learned about position time graphs, we said that if you look at the slope of a position time graph, you can describe the velocity because slope is rise over run, and on a position time graph, rise over run is delta x over t, which describes the velocity. Well, in a velocity time graph, in other words, if your y-axis is not position, but instead it's the velocity, the slope or the rise over run becomes velocity over time. That describes the acceleration of an object. Okay, so we're going to look at this graph. We're going to split it into different parts, and we're going to look at each part and describe the slope, thereby describing the acceleration of each section. So let's first start by splitting this up into different sections. I will call this section 1. And this will be section 2. This will be section 3, section 4, and then this right here will be section 5. All right, so again, remember, to describe the velocity here, we're going to describe the y-axis. The y-axis is the velocity. Okay, to describe the acceleration, we are going to describe the slope of the line. Okay, so let's look at the very first part of this, which is this slope here that I've highlighted in green. We can describe that slope as being positive and constant. So we'll say it's a positive constant slope. I can replace the word slope with the word acceleration. I'm describing the acceleration when I describe the slope. Okay, now let's describe how this car is moving. This car is moving forward. This car is moving forward. How do I know it's moving forward? Because my velocity is in the positive area of the y-axis. I have positive velocity, and it's speeding up, going faster. How do I know it's going faster? Because I know the acceleration or the slope is positive. Okay, and when the velocity and the acceleration are both in the same direction, both positive or negative, but both in the same direction, then your object is increasing in speed. All right, let's look at the second section here, which is this section that I'm highlighting in purple, section 2. So if I were to describe section 2 slope, I would say that section 2 has 0 slope, which can also describe its acceleration. What this means is I'm still moving. The only time on this graph that I'm not moving is if I'm on the 0 place on the y-axis. Okay, if I were to just put some arbitrary numbers in here, you will see that the only time that an object stops is if its velocity is 0. But in section 2, the velocity is not 0. The velocity is 5. Okay, so with a 0 slope on a velocity time graph, that doesn't mean you've stopped moving. It just means you're still moving forward, and I know this because my velocity is positive on the y-axis, but at constant speed. Meaning I'm not accelerating or decelerating, I'm at constant speed. All right, section 3, keep with the same pattern here. Section 3, which is this purple part here, I can describe that as positive constant slope, synonymous with positive constant acceleration. And the way that I would describe this motion is I'm still in the positive area of the y-axis, so I'm still positive velocity or moving forward. And getting faster. And how do I know I'm getting faster? Because my slope or my acceleration is also positive. Okay, and then number 4, section 4, which I'll do in blue here. It's kind of hard to see. Let me make it. Okay, section 4, I can describe the velocity by, well, let me describe the slope. The slope is a negative constant slope, which is a negative constant acceleration. And that means that I'm still in the positive area of my y-axis, so I'm still moving forward. I know that feels counterintuitive to say, no, you're going backwards towards your starting position. No, that would be true if this was a position time graph. But in a velocity time graph, the y-axis describes the velocity. So you're moving forward because you have positive velocity, but you are slowing down. Slowing down because your acceleration is negative, right? So you were starting at, you started up here at 20 meters per second, then you became 15 meters per second, then 10, then 5, and then eventually you got to 0 at the bottom of section 4. Okay, so you'll notice because the velocity and the acceleration are in opposite directions, you're slowing down. Okay, we talked about that yesterday. All right, and then in the last section, section 5, if I'm describing the velocity, let me stick with the slope. The slope is negative and constant. Or negative constant acceleration. What does that mean? Now look, what my velocity is negative. I've dropped below the 0 line on my velocity y-axis. So I'm going to say that now I'm moving backwards. I'm moving backwards because my velocity is negative. And I'm starting at 0, and then down here is, let's just call it, I don't know, -5. So now I'm going faster than I was at the start of section 5. So I'm speeding up. Why am I speeding up? So look at the sign of my acceleration, which is negative, and my velocity, which is also negative. So when velocity and acceleration are in the same direction, you're always going to speed up. Okay? All right. So go ahead and stop this. Well, you're going to answer the questions on Canvas. Then you will go and try the velocity time graph fix-in on your own, and then watch the video to see how we do it.